Hi everyone, in this video we're going to talk about how selection works within a microbit, adding on to the code that we did from last week's lesson. So before we need to go on to that, we need to understand what selection actually is. Well, selection occurs in life all the time, constantly. Selection is when we choose what to do in a certain situation, or specifically with code, choose what code to run based on a certain condition. So in real life, as I say, we do this all the time. So for example, if it's cold outside, we'd put a coat on because otherwise we'll be cold, wouldn't we? But we wouldn't do that if it's hot, so else don't put a coat on. So if it's cold, put a coat on outside, else it must be hot outside, so therefore we're not going to put a coat on. I know it's a random example, but you know, it makes the point. Now, when it comes to doing code, we can't just say, it's hot. We need to be more specific inside of a computer. So we use comparative operators, which are the fancy words for these symbols just here. Now, hopefully you've seen these in maths before, but in case you aren't aware, we've got less than or equal to, greater than, and greater than or equal to. Also should be putting equals in here as well, because we are going to be using that a lot today for today's lesson. So if you've got two values, you want to compare one against the other, and if those two values are right, then we can do something. So what does this mean inside of Microbit then? So selection is controlled almost completely by the logic section of Microbit. So when you need to make a decision, you can use this logic section because you're choosing logically which piece of code to run. So here is an example for you. So this is slightly more complicated than what we've done last time. So let's break it down into piece by piece. So what does this program do? Well, let's have a look. Now, even though we haven't done on shake, it's pretty obvious that if we were to shake the microbit, that's going to cause this code to run. We're not doing it on start, we're not doing it forever, we're doing it only when the device has been shaken. Now, this block is something called a variable. I'll go into more details of the notes later, but basically a variable is a value that we can change as the program goes on. So we've said, okay, we're going to set the temperature, temp, to be the temperature. I'm not sure if I told you last time, but the microbit also has a thermometer on it as well. So it has plenty of functionality. So we can set the temperature to be the current temperature in the room. That's basically taking the information from the microbit and putting it into the program. And then we can say, well, if this value, this red variable, this temp, is less than, so that is definitely a less than, make sure you're pointing the right way with these things, otherwise it'll all go horribly wrong. If it is less than 20, then we're going to put our coat on, aren't we? We only want to put the coat on if it is less than 20. Else meaning the opposite of that, so else if the temperature is not less than 20, it must be 20 or more, therefore we're going to take our coat off, because therefore otherwise it would be very hot. So that's kind of how it's unpicked. We'll go through another couple of examples in a second. So I do refer to variables just a second ago, and a variable is a really key core concept in programming. We're going to do it a lot next year as well. It's when a value changes while the program is running. The temperature might be 15 degrees when it starts. It may be 25 degrees if you're in a wildly changing climate. But it changes generally, and little subtle changes happen all the time. So we need to store those values so they can be controlled by our program. The value won't be read unless it is put into a variable. So it's really important that we use them. And the variable in this program, as we said before, is temp. Temp is just a name we've given for temperature. It's not a set name. We could call it Bob if we wanted to, but that would be a terrible program because we don't know what the hell Bob is. So temp is a lot more useful. So let's combine a few of these features. In fact, let's not do it in here. Let's actually look at Microbit itself. So what I'm going to do is I'm going to just talk you through the process of making a dice work on the Microbit. Now to do this, actually, last time I said, most programs use OnStart and Forever, but this one doesn't. So I'm going to throw these ones in the bin. And I want the dice to be rolled when I shake it, which makes sense because that's a logical thing to do. So to do that, I'm going to go into my input section and go on shake. If there's anything the user has to interact with, it makes sense to use the input section. So now I want to actually set my value to something. Now, I'll set a value to something. Obviously, when you roll a dice, you've got a choice of going between 1 and 6. So I'm going to go into my variables here. And I've got the option to make a variable, which I'm going to do. And I want to pick a random number between 1 and 6. So just for the sake of argument, let's call this variable random. As I say, it doesn't really matter what we call it, but it is important that we give it a name. Now we want to set this random to be something. Now, luckily, we don't have to worry about programming this. What we can do is we can go into Microbit's code. Now, there are two ways of accessing blocks if you don't know where they are. For the example, we should know that random is to do with numbers, and numbers are going to be in the math section. It's American, let them have that one, but it should be math. But even easier than that, let's go into the search bar at the top, and we know we're looking for random, aren't we? So if I put random in and search for it, it will now give me all of the options that relate to random. Lots of things I don't need, radio for some reason, but I do want to pick a random number between two values. So this one is what I'm looking for here. Now you'll notice that this is kind of oval shapes, or rounded rectangle, I guess. Now that has got the same edges as the inside of this block, and you'll notice that the two try and marry up when I put them close together, which is exactly what I'm after. But I don't want to pick a random number between 0 and 10 because that would be a very weird dice. Obviously I want that to be between 1 and 6. So I've got a random number between 1 and 6 now, which makes sense. And just to show you that working, if I was to go onto basic and show number, obviously I don't want to show number 0. What I can do though is go back into my variables section and I can show this random. And I can press play on that. And then on shake, I've got my little shake button at the top. On shake, it will show me a new random number. And that's all very nice, but it doesn't look very much like a dice, does it? This does work, so you could very well use this, but we want to be a little bit more complicated with it, a little bit more accurate. So let's stop that for now. Let's use selection. So in here, we're going to use logic. Now, you can use either of these conditional blocks, but for the moment, I'm going to use the if-else block. And actually, I'm going to remove this show number because we don't really need it. So if something, and you can see we've got a bit of a hexagon in here, so we need to find a hexagonal block to fit in there. Well, luckily, if you were very eagle-eyed, you may have noticed back in this logic section, we've got these hexagon blocks underneath. Now, I always pull this first one because you can always customize it to do whatever you want. So I'm going to put it straight in the block because it makes sense to put it straight there. Now, if 0 equals 0 is obviously not what we want, what I want to do in this section is say, oh, if the random number was 1, then I want to show the 1 image. So let's go, we need to think about this a little bit. So obviously I want this to be equal to 1, so let's change that to 1. But what do I want to be equal to 1? Oh, it's having a complaint at me now. 0 can't be 1. But what can be 1 is the value I set earlier. So if I say if random is equal to 1, then something can happen. It's not complaining at me now. Good. So if random is equal to 1, then I want to show something. So let's go into basic, because that's where all of our blocks for showing pieces of information are. I could just show the number 1, but that's a bit boring. Let's put show LEDs and put like the pip for showing 1 in there. That works. So if I press play on that and press shake, probably not going to show anything. Oh, there you go. It has randomly picked 1 on that one instance. So that's good. So that does work, but it's only doing one thing. We needed to do a number more. Now, we could use this else at the bottom, but because we're picking a random number between 1 and 6, if I get a 1, this is going to happen. But if I get anything else, I've got one other response, and that's not really good enough. So what I can do is, if you look here, we've actually got a plus sign we can use. So if I press that plus sign, we've got the option to add more sections. So I'm going to actually take this this block out here. And if I click it and hold it, if it lets me on the iPad. Okay, normally you can duplicate this. If you right click on your computer, you can duplicate it. Because I'm fancying using my iPad, I've got to do more work. It's my own fault, really. So I'll just pop that in here and say the same again. Not this time, we don't want if random is equal to 1. That's not happened in this instance. We want it to see if it's equal to 2. And we don't want it to be 0 equal to 2. It's probably going to go red again. Yeah, there you go. We need to make it so it's random is equal to 2. And if it is, once again, you can probably see how this works now. This is going to be 2 as well. Let's put it the right way around. So if it's 1, it's going to be showing the 1 pip. If it's 2, it'll show the 2 pip. Let's just put this in. I know it's not accurate because we haven't got all the dice numbers in there, but we can see it's 2. Let's see if it gets 1 at any point. There you go. So it does change. So it does work. Now, obviously, you would do this for 1, 2, 3, 4, 5. In fact, let's just not be lazy. Let's put those in there. If it lets me. Oh no, it's going all over the place. Let's have a look. So I've got 1, 2, 3, 4, 5 slots. So we want to have another one, 6th one. So I'm not going to show you how it works doing it all now because we haven't got masses of time. But if I had random equals 2, then 3, 4, 5, what I don't have to do is say if random is equal to 6. Because if I've already found out that random isn't 1, it isn't 2, it isn't 3, or 4, or 5, it must be 6, because it can't be anything else. Because we've said here, pick a random number between 1 and 6. If it isn't 1 through to 5, it must be 6. So just to make the point that in the last box where it just says else, you don't need to say else if it's 6, because it can't be anything else. It's much more efficient inside of a computer to leave it like that. So I'm going to leave it at that for now, just so you can see that that's how that's been constructed. There are a couple of tasks which are similar to this. You won't get the dice task, but you'll get one which is very similar in the rock, paper, scissors task. So if you do get stuck on that one, do have a look at this video again, and I've put an image of the completed version of this code in the task 2, so you can see what that looks like if you want to have a go yourself. Okay, if you have any problems, let me know, but otherwise I'd be curious to see what you all come up with.